So let's check this exam problem. We have a tensile member that it is constructed by connecting two plates as shown here. Each plate is 0.5 inch multiplied by 9 inches and the grade of the steel is 50. The ultimate tensile strength is 65 KSI, and the fasteners have 0.5 inch diameter holes. Disregarding the eccentricity and the block failure, what is most nearly the maximum tensile load the connection can support? Here we are disregarding the block failure. This means we have now two modes of failure, which is either yielding or rupture failure. So we are going to check each failure mode, and whatever the lower value for the tensile load, this will be our governing value. So first let's start by yielding. We know that the phi Tn equals T ultimate, and phi Tn is going to equal phi multiplied by area steel multiplied by F yield. We have these values here. So the phi Tn equals 0.9, which is the phi for the tension, multiplied by 9 multiplied by 0.5, which is the area, multiplied by 50, which is the F yield. This is going to equal 202.5 kips. Next step, we are going to calculate the same for the rupture. We know that this is the equation for the rupture, which is phi Tn equals phi F ultimate area effective, and we know that the area effective equals U multiplied by area net. Here it is saying that we need to disregard the eccentricity, which means that the shear lag factor equals 1. So we need to calculate area net now. Here, this is we need first to choose which line of rupture we are going to choose. Here we have only 2 bolts, so we are going to choose this line which has 3 bolts, because this is going to be our critical line of rupture here. So let's calculate the area net here. It is going to be 9, which is this height, minus 3 multiplied by 0.5, which is the whole diameter, plus 1 over 16. Here you need to take care that this 0.5 is the whole diameter. So you need to add only 1 over 16 to compensate for any damage. You don't need to add 1 over 16 and another 1 over 16. You are going to add 2 if this was given as the bolt's diameter, but here it is given as the whole diameter. So all of this multiplied by 0.5, which is the thickness of the web. This means that the area net equals 3.56 inches square. This means that area effective equals 1 multiplied by the same. It is going to be the same, 3.56. So the phi Tn equals 0.75, which is the phi for the shear, multiplied by 65, because here this is F ultimate, multiplied by 3.56, which is the area net, which is going to equal 173.6 kips. Of course, we are going to choose the lower value, because this is the value of failure at the yielding, and this is the value of failure at rupture. So we of course governing the section by the lower value, which is 173.6. So this is going to be our closest answer, which is C, 170 kips. Thank you, and see you in our next video.